Greetings, people. This is Keith Modesto doing my Let's Play Minecraft series using the Direwolf 20 mod pack. And what is it? Let's I can't remember exactly what I ended with on the last episode, but I've been working on a couple things between episodes, so I want to show that. I guess I was just finishing up some last details of my rail system here, my little in-base rail system. See, I want to go to the middle of the hall. Okay, so the first thing I want to show that I've changed is I added some more steam dynamos. I had 8, which is the stuff on the bottom. So I added 8 more up on top. So I doubled the number of steam dynamos. The next thing I did is, the other thing I did is I switched out. Oh yeah, I was thinking of doing this. Oh well, maybe I will after I do something, show something else. But I switched out the kind of cabling I was using. This was opaque item ducts from thermal expansion, and I switched that out for the whale is not showing the name correctly, but these are transfer pipes from extra utilities, and I think they're going to work better because there is a problem where with with the item ducts from thermal expansion, the items that were being transferred, in this case charcoal, they would get backstuffed. What would happen is one of these, and I actually showed this like 2 episodes ago or something, and I did something that I thought might fix it, but it didn't fix it. I mean, it made the problem was less pronounced, but it was still happening. So each one of these steam dynamos is holding 64 pieces of charcoal. They're all full because they're not running right now. But if they were running, each one would use up 1 piece of charcoal, right? It would start burning it, and then they would each get another piece of charcoal from, well, before it was from the servo in the opaque transfer pipe, the opaque item ducts from thermal expansion. They would deliver the charcoal to the to each steam dynamo, but apparently item ducts are not smart enough to figure out how much they should send. It just starts sending, it just starts sending like a stack, or how you can set it. How much do you want it to send each time? But whatever that is, it just sends the whole thing. And if it takes it a while, the items a while to get to where they're going, they send too much, then it's going to end up actually sending more than they need to, and those items will bounce back, and they can't go back in. I actually tested this with a regular chest, a vanilla chest, not this deep storage unit. I thought maybe part of it was a bad interaction between the item ducts and the deep storage unit, like it just couldn't go back in the output. But apparently it's, at least with it's even the case. It does the same. It has the same behavior with a vanilla chest. If I was testing this. I guess I might shut this on camera. There's something in my eye. You put a vanilla chest down right here. Put another vanilla chest over here. Like, actually, I made this vanilla chest double in size. Filled it up with blocks, stone bricks, and then I connect them with item ducts, and then wrench it so that this one is outputting, and then put a servo, or actually I think I didn't use the servo, I think I just used a lever. Anyway, so turn on the lever, so it'll start pumping out stacks of the bricks, whatever you put in there, over to the other chest. Now, because this chest is twice as big as this chest over here, you made this a double wide vanilla chest, and the one over here is just a single vanilla chest. If you fill this one up, then pretty soon this one is going to be full, and there's still going to be items over here, but the servo will or actually it's not a servo, it's just the lever. But anyway, this item duct here, the one that's connected, that's outputting, will still keep on pumping out blocks for a little while until they start bouncing. Then they'll start bouncing back. They'll just start bouncing back, and they'll jam up. It's called being stuffed up. You can see it in Wayla. It'll stuff up the output of this chest over here, and then once it's stuffed, it'll stop. But I don't know, maybe that's not a big deal. It'll just stay like that until I can output more. But actually over here, when that would happen, charcoal would start falling out and onto the ground and, making a mess, which is kind of a problem if that happens. That doesn't seem to be happening. That's not happening with the transfer pipes, and these work a little bit differently. If I can get in here without breaking anything, this is the transfer node, and if I click on it, I get a little interface. I have one speed upgrade on this to make it go a little faster. I'll take it out to show it's going slower. There's a little buffer. It has just one square here. That's a little buffer for whatever's in the storage unit. Whatever inventory it's pulling out of it. It has got this one thing for a buffer. So I can see here the next thing it's going to transfer, if it transfers anything, is charcoal. So up here you can see searching for inventories at. It's actually going. It's actually the node is searching down the path here, and there's two different ways it can go. You see there's transfer pipes underneath all of these dynamos, and then there's more transfer pipe going along the top of the dynamos, to get charcoal to all of them, because they need that to burn to make the steam. They burn charcoal. Anyway, so it's searching down the paths along the X, Y, and Z coordinates. That's what it's showing right here. So that's to help you figure out what's going on. Also, there's some kind of item, I don't remember what it is, but there's some kind of item you can hold in your hand that'll allow you to see. It'll make these little particle effects go along. I don't have that. Maybe I'll show that sometime. I don't remember what it is you have to craft to do that. I could probably look it up in NEI. But anyway, so it's X, I guess, is this way, right? So it's got a lot longer to go down the X. Anyway, what the point is that it's actually searching for some place where it can insert something before it ever even sends something down the line, which means it can't ever really have items bouncing back or back stuffing. Unless, well, I guess if it started, well, I don't know if it actually takes time, when it decides, oh, there's room for something, I'm going to send this charcoal down the line, because, say, I pulled out all the charcoal out of this. If we go over here, I don't know how, if we can get here before it happens. We might have missed it. Well, say, I just pulled that out, right, and it's probably already full again. I don't remember which one it was. Well, anyway, as soon as it sees that there's, oh, it's this one, so it's not still full. This is just 3 down. We'll see, we might see it happen. Anyway, oh, it did. See that? And now the buffer's filling up again. It takes a little while. So I don't know. Once it says, oh, there's an inventory I can put charcoal in, it sends the charcoal down. Does that happen instantaneously, or does that also take a little time? If it happens instantaneously, then nothing can ever bounce back. If it actually does take a little bit of time for the charcoal to go down the pipes to the inventory that the node just figured out there's room to put something in, then actually you could take items out of that inventory, wait for the node to say, hey, send something, then the node sends something, then you quickly put that stuff back in that spot, so it's full now. Then those items, they get there and they say, oh, I can't go there, and then go back. That might happen. I don't know. I don't know behind the scenes whether or not that when the node decides to actually send something, if that's instantaneous or not. But the main thing is it doesn't start sending something until there's room for it. Okay, so that should fix that issue I was having. And the reason I wasn't using these things before is because, actually, you can get in here right there. I can click on the node. The node there, the recipe for that takes ender pearls. The pipes, maybe I should show this. Transfer. If I put in transfer, actually, I'll get both of them. Transfer. Okay, so transfer pipes, that's what these are. Whoops, those are transfer pipes. And there's actually a couple other kind of pipes. But transfer pipes is the most basic. Excuse me. Not hard to make at all. Just some stone slabs, which is just made from stone. Some glass, and just one piece of redstone gives you 32 transfer pipes. That's a lot. So transfer pipes are not expensive at all, really. As long as you have a little bit of redstone, you can get a lot of transfer pipes. But the transfer node, is not too bad, except that it takes an ender pearl. There's actually 2 recipes, I guess. That's just information. Okay. You get just 1 transfer node for quite a bit of redstone. That is a little more expensive, especially early on when you haven't gotten a lot of redstone yet. The pipes, 32 for just 1 piece of redstone. That's not bad. Early on. I mean, how much automation are you doing early on? But a whole block of redstone is getting a little bit. But then if you use an ender pearl instead, you get 4 nodes. That's better. I'm actually only using 1 node in this little setup, but if you're doing some other things, it can be easy to need a couple of nodes, right? So it's nice to be able to craft 4 at once, but it takes an ender pearl, and early on, it can be a little bit hard to get ender pearls, and you might want to save them for something else. Ender pearls are not a problem right now, actually, of course, because I have the auto spawner, so anytime I get low on ender pearls, I can just start spawning some endermen and killing them. And get as many ender pearls as I need, so, which is why, that's why I hadn't used these before, is because before I didn't want to spend the ender pearls on them. Not that I didn't go looking for endermen early on to try to kill them to have some ender pearls, but I didn't have much luck. Anyway, so there's that. Now the other thing, let's see, I can show real quick that I put a carpenter in here. This is from forestry, and I have it here so that I can make wooden ties. Wooden ties are necessary for making rail beds, and rail beds are necessary for making tracks. And inside the wall here are pipes for bringing in energy and creosote oil. This thing takes creosote oil, at least to make wooden ties. This carpenter can make different things. There's like different recipes, special recipes for the carpenter. And they don't all use creosote oil. Sometimes you need other things in here. But anyway, so this is set up for making rail ties, so that's good. Okay, then I want to show this. I have had this computer here sitting underneath this redstone energy cell for a while with the intent of setting up a little program to monitor the energy levels of this cell so that it could automatically turn on and turn off all these steam dynamos to keep these 2 batteries fully charged, right? I mean, I could keep them fully charged by just keeping the dynamos on all the time, but that would waste a lot of fuel. Not that I don't have a lot of charcoal in that deep storage unit, but because there is a lot of charcoal in there. But still, I don't like the idea of just keeping engines running all the time when they don't need to be on. I mean, what are the batteries for if you just keep the engines on all the time? Anyway, so here's the program. Right now it's running. It's every 30 seconds, I think, it goes through a loop and it prints out the energy level. And if this gets down to a certain level, I call it the trigger level. It's just reading this one redstone energy cell. This is where the energy drains from first before it drains out of this one. I mean, the energy flows is going this way, so it's pulling energy out of this, but then this cell's pulling energy out of this one. So this cell would drain all its energy before this one did, right? So I just monitor this cell and make sure this cell is topped off. The program on this computer, it checks the level on this redstone energy cell, and when it gets really low, then it turns on the engines, and then it keeps on monitoring them so that once it gets close to being full, it turns them all off. Anyway, so I'm going to show you this program right now. So I got to terminate this by hitting Control T there, and then I can do a list, and I'll show the programs on here. OpenP and ROM are on every computer when you first make it. What's called OpenP here didn't used to be called OpenP, I don't think, before. But anyway, that's just a directory full of a couple of programs, maybe. Oh, maybe I should show that. And ROM, I think, is the operating memory, so to speak, of this computer. So I do a list here. You can see, there's docs. This is information. I think this is just information about how to do certain things. I looked a little at docs, but not at the other stuff. Oh, OpenP stands for Open Peripheral. That's right. So I guess Open Peripherals added the OpenP directory in there to put in a little bit of documentation. Okay, so we got to back up. Okay, so back to this. Okay, so monitor rec, I wrote that, and startup, I wrote that. Startup. Anytime you have a monitor or a turtle, a computer that is, a Minecraft computer, this is from Computercraft. Um, anytime you have a program, and these little programs are all written in Lua, which is a scripting language that's just which is kind of C-like, I think. Anyway, so anytime you have a program called startup on a turtle or a computer, when that turtle or computer first boots up, which will happen if you actually, there's a command you can use to actually force a computer to restart. It also happens whenever you start the game, I think when a chunk is loaded. So if I left this area and it weren't chunk loaded and I came back, it would reboot, I believe. Anyway, so whenever the computer boots up, the first thing it does is it looks to see if there's any program called startup, and if there is one called startup, it loads that program and starts to run it. And startup can be anything you want, right? To write a new program, you just write edit like this, edit test, and now I have a program that's called test. I can put anything in it, and then save, and then exit. You get this little menu at the bottom by hitting Control, and then I do a list. Now there's a program called test. If I do edit test again, it'll open that up, and there it is what I just did. I'll delete that later. Anyway, so monitor. Edit startup. It's just a shell command, shell.run, and it runs monitor rec. That way you can switch things out and stuff. It's just a little clever way of setting things up. I could also just rename monitor rec to startup and it would do the same thing. Okay, so let's show what's in monitor rec. Monitor rec stands for monitor redstone energy cell. Okay, and I got a little bit of commentary at the top of this to explain what it does. That way, if I look at this in a couple of weeks and I don't remember anything, I can look at this. What is this thing doing? And I go, oh yeah, it's monitoring the redstone energy cell. I probably should put in a little more comments actually inside what it's doing to remind myself of what it is. But I give things names, the variables names, so they make sense to help me to figure out if I'm looking back at something. What is this thing doing? Anyway, so first we set up some variables. Bat is the battery, the redstone energy cell, and so this peripheral.wrap is telling the peripheral.wrap is actually from Computer Craft, but the fact that I can do this with a redstone energy cell, which is actually from another mod, is added in by open peripherals. Anyway, so peripheral.wrap is telling it, hey, there's something right directly above you. That's what that top is. It's telling you what side the peripheral is on in relation to the computer. So saying, hey, on top of you, computer, there is a block, and you can interact with it, and we're going to call it battery. And then from then on, I can access methods of that peripheral by using this is kind of like an object. Lua I don't think is really object oriented, but this is kind of like being object oriented, or an API or a function or something. So battery.get max energy stored is going, and you still have to put top in, which is a little odd. I had to do some searching on Google, and because I was trying to do this and it wasn't working, I was getting errors. So it's a little odd that you have to put in top when you call get max energy storage, since in the previous line I just told the computer that the battery bat is right above it. You really shouldn't have to tell it that it's on top again, but apparently you do. Anyway, so that is going to put in this variable max a number, which is how much energy that thing can store, the maximum amount of energy. Then I set trigger to be just 5%. Max is, trigger is now set to 5% of max. So if max were 100, it's bigger than 100, but if say it were 100, then trigger would be 5, right? And then I set shut off to be equal to 95% of max. So if max were 100, shut off would be 95. Then we go into a while loop. This is the main thing. There's one big while loop, and it's always running because I put in true, and it's the condition it tests. So while true, do this stuff. And then there's stuff inside the while loop, and then that while loop closes at end, and that's the whole program really. Is this one while loop that's always going to run. And you notice at the bottom of the while loop there's a command called sleep, and this is important. Whenever you're doing something like monitoring the energy level of a cell, anytime you're monitoring something, the program's going to be running all the time basically. So a while loop with a true in it as a conditional is pretty common to do that. But if you're doing that, you need to make sure that the while loop is not just running at full speed all the time, so to speak. I mean, really it is, but you need the computer to pause, because otherwise it's gonna like it's gonna bog down your system, the whole game, right? It's just really a bad idea. So sleep, if you have the sleep command in here, is telling it to sleep for 600 seconds, which is 10 minutes, I believe. So each time it goes through this while loop, it's going to pause at the end before it does the loop again. Anyway, and then there's actually another while loop inside this while loop, but let me just go line by line here. So power level, and if you don't like looking at code, you can skip all this, but I'm doing this so if anybody, there's someone who's been interested in programming these computers and doing things, but doesn't really know much about how to do it, or is a little intimidated by it. I'm just showing, a real life application of this that, I've had it running and it hasn't crashed, so I think there's no bugs in this, but, see, and now I'm out of time. So anyway, here, I'll go through this and then I'll wrap things up. This is gonna go a little long. I was afraid that would happen. Anyway, so the first thing it does is we have a variable here called power level. In Lua, you don't have to declare your variables before you use them, apparently, because this works. Because this is just a simple scripting language. You're not doing anything. You're not supposed to be doing something really, really complex. But I think you can declare the variable first if you want to. And you don't have to tell it what kind of variable it is, whether it's a string or a number. The language will figure it out. Which means you can't get in trouble if you do something really wrong. But anyway, so power level is equal to this bat, which is the redstone energy cell above, and then get energy stored. That's a method, and it returns how much energy is actually in the cell right now, not the maximum level, which was the previous method. That was get max energy stored. This is just get energy stored, and again, you have to tell it it's on top for some reason. So say the max were 100, and right now it held just 50, then power level will be set at 50. Then I print out the power level so that, if I come up to this computer and say, what's this computer doing? And I click on it, I'll see it saying energy level is this, and I'll remember, oh yeah, that's what it's doing. And it won't be just a blank screen. I'm wondering, is this computer doing something? Anyway, so it's a good idea to have something on the screen, some kind of feedback so you know what the computer's doing and everything's doing what it's supposed to be doing. Anyway, so I print that out. You don't actually have to print it out for it to do what it's supposed to be doing, but I like it to do that so I know that it's actually working, right? Anyway, and that's also why this light is here. I'll explain that in a moment. Okay, so then we have an if statement, so it's going to check something, and this is a decision point. So if the power level is less than the trigger, so the trigger is 0.5 is 5% of the max, which means this is saying if the energy cell is really low, that is, it's only got 5% of how much energy it can store. It's almost empty. Then we're going to do stuff. Otherwise, it's just going to end. The end of the if statement is right here. So if it checks that every 10 minutes, it does that check. That first if is done at the beginning of every while loop after printing out, first it finds out what the energy level is. We print it out, then it does the check. What is the energy level? Is it less than the trigger? And that happens every 10 minutes. Every time this while loop every time it goes through this while loop. Right, so it does this if, then you see the end of the if is all the way down here, and then it does the sleep. All right, so if the power level is over the trigger, it's just going to skip all this stuff right here that's indented. But if it is lower than the trigger, then this happens. We print out the energy levels are low. That way, I can look at it and see that the computer is doing what it's supposed to be doing, and it's working. And then it sets the redstone output. It uses this redstone dot set output. Set bundled output left to white. That has the effect of turning on all the engines, because right here we have RedNet cable. RedNet cable works well for this. I showed in the last episode some kind of interaction between RedNet cable and Red Alloy wire that was not working well, where RedNet cable was not a good application, but here it's working fine. So RedNet cable has all these little bands, so you can set them to whatever color you want. By default, they're white, and I've left them all white because, It is not necessary to change them to any other color, but so they're white. So if I switch this lever, actually, and there's also a manual way to turn all the engines, right? I have a lever right here that has that sends a redstone signal down the white channel to all the dynamos, so they're all running now, and now they're charging up the energy cell. I'm gonna turn it off again. So this light turns on when there's a redstone signal on the rednet cable. That way, if I'm walking by, I can say, oh, all the dynamos are on. Of course, these light up too, but this is really easy to see. Anyway, so this line right here, redstone.set bundled output, that's line 18, the one that the cursor's on right now, right here. Okay, so left is because the cable is connected to the computer on the left-hand side. And then colors.white is because I want the white color to be on. That's the frequency all these cables are set to. And that actually has the effect of turning the redstone signal on. It's like that's colors.white is like true. If whatever color you set this to, that is setting that frequency to true. If you want to turn it off, you set it to 0, and that happens a little bit further on. Anyway, so that's the first thing you do is turn on the redstone signal because we want all those engines to turn on because the power level's too low. Then we immediately go into a while loop, and what the while loop checks for, that's line 20 right here. It checks the power level again. The power level is still set for what it was. We checked it. We set it just a little ways above, right? So we check the power level and see if it's less than the shutoff. The shutoff is 95% of the maximum level of the redstone energy cell. So shutoff is when it's close to being all the way charged up again. When it first gets to this while loop will be right after it turned the redstone signal on, when the redstone energy cell is really low, right? So the very first time this gets checked in this while loop, it's gonna fail because we just turned the engines on. They're not gonna have charged up the energy cell already. So which means that we're gonna enter the while loop, and the first thing we're gonna do is sleep for 30 seconds. That's gonna give some time for the cell to charge up. Then we're gonna actually set the power level again. We're gonna call the method get energy stored at the top. That's gonna reset power level to what the power level of that energy cell is right now. How much is in there right now? And we're gonna print out the energy level, so we have some visual feedback on the screen of the computer, and then the while loop ends. That's it. Because once we get here, it's going to go back up to the top of the while loop and check the power level again. Is the power level less than the shutoff? And probably the second time it goes through this, we just entered it. We slept for 30 seconds. We checked the power level. I mean, we didn't check it. We just set the power level. We just took the measurement, so to speak. We took the measurement of the power level, and then we go back up to the top of the power loop and we check the power level again. So eventually, it might take a little while, but eventually we're gonna check, sleep. Then we're gonna get to a point where the power level is gonna be over the shutoff. The battery is gonna be almost fully charged, and then this while loop will fail. It'll check and it'll say, oh, it is over the shutoff, so we'll exit the while loop and get down here, and we'll print. The first thing we'll do is print out that we've chopped off the energy cell. It's going to be close to the top. Once you turn off once you turn off the dynamos, it takes a little while for the energy for them to stop, and for the energy to trickle out to the energy cell. So that's why I made it 95% and not 100. So it'll be close to the very top once everything's done. Okay, so we print out that message, and then we do we call this method, this is on line 27, right here, redstone.set bundle output left to 0. 0 has the effect of making sure all the channels, all the frequencies, all the colors on the rednet cable are turned off. There's no redstone energy signal. There's no redstone signal going out on any of the channels, which turns off all the dynamos, and then that's the end of this if statement. And so it gets down to this line, sleep, which is on line 30. It sleeps for 10 minutes, and then it goes back up to the top to the while loop, which it's always going to execute because it's set to true, and it starts the whole thing over again. It checks the energy level. It does the measurement of power level, prints out the message of what the power level is. So say that right now the battery is about 2/3 full, and it's going down because there's machinery up there running the farms and stuff. So, but it's not almost empty, which means when I run this program, it's not going to trigger the inner while loop where it actually turns on the dynamos. So which means that every 10 minutes, when this thing is running, every 10 minutes it'll print out a message about what the energy level is, right? And it prints it out and then checks the trigger, and if the power level is above the trigger, it just skips this whole if and the inner while loop, and sleeps for 10 minutes. Right there at the bottom. That is basically that is the program. It's not too long, and I think the logic works pretty well. It's not the whole point of this is so that the machines are only running when we need to charge up this battery. I've got this other battery here, which means that when this is really low and I say, oh, the battery's the energy level's low, I need to start running the engines. There's still plenty of energy in this battery to keep things going while we top this battery off. So there's really never any danger of running out of energy, unless eventually have so many machines running so often that this whole system just can't produce energy fast enough to keep up, in which case I just need to install more engines or something, right? So let's go ahead and start this running. So I could type startup, or I could type monitor rec, or I could do this, which is to reboot the computer, which you can do by just typing reboot. It's going to say goodbye, and then and it actually starts the computer up again. And then you can see it printed out energy level, which is what the energy out level is right now. You can see that on Wherein, right? Right there. Right, it's going down. And now, if we came back in 10 minutes, it would print out energy level, and it would be a new number depending on whatever this was in 10 minutes. It'll be, I don't know, maybe down to there about, maybe a little more. So that is it. That's my little system for that. I don't know what took me so long this has been sitting here for like 2 or 3 weeks or something without me doing anything about it. So I guess we need to wrap up. This is gonna be a long episode because of that. So if you don't like code, sorry, but I thought some people might like to see that. The next thing I'm gonna do, I guess I'll show this. I'll show this recipe, but I'll get this set up and we'll do this in the next episode. I'm gonna make a cart dispenser. I'm going to make 3 cart dispensers right here from Railcraft. So I need to, that's not very hard, it's just a dispenser and a minecart. Yeah, that's very easy. I'll do that on camera and put them in, and probably an ender chest, 3 ender chests, so that I can have, I can automatically dispense carts. Oh yeah, that's right, I need to set up things that'll pull the carts in. I need to look up exactly how to do that. That's not something I've done before. But right now, the cart is right here. If I were doing stuff and, found myself outside and suddenly it was at the tower and I never used this to get to the tower and I was down there. So I came down and I was all the way over at that end and I wanted to get back to the original base. Well, right now the cart isn't over there. It's over here. And I wouldn't now I have to walk over here because there's no cart over here. So I want to make it so that there's a cart in every spot. And I don't want the carts to just be sitting here because, there'll be collisions there could be collisions between carts, when they arrive if there was a cart here already. So instead the carts will be stored in a dispenser, which will automatically dispense or something like that. That's what I need to look up. Making the dispenser is not hard, but how do you get it so it automatically dispenses the cart? I need to look that stuff up. But that'll be the next episode. This has been Keith and Medessa playing Modern Minecraft with the Direwolf 20 mod pack. Thank you for watching, and I hope you have a fantastic day.